Hello, welcome to another video of CS360, and this video will be covering pushdown automata. Uh, Pushdown automata. So these are machines that, so a pushdown automaton is to a context-free grammar as an NFA is to a regular expression. So these are machines that characterize the context-free languages in the same way that DFAs and NFAs characterize regular languages. Okay, to introduce pushdown automata, so there's a formal coverage of this in the notes, but I kind of wanted to focus more on the diagram version. So pushdown automata, they well, they have transition diagrams that look kind of like the ones for NFAs. So we will have a start state, right? We'll have a start state, and then we will have as we transition, we're going to have a notation that label the arrows not just with zeros and ones that say symbols that we read from the input, but also with symbols that we can push or pop from what is called the stack. So let's say that we start by pushing a symbol, see this diamond symbol onto the stack. Okay, so we will denote push by a down arrow. So kind of imagine placing this on top of a stack of cards or something. Okay, so we put the diamond on top. And then we transition to a state Q1. And then we will have more transitions. So for example, let's say that we transition here. This is going to be labeled 0 to a state here, Q2, and then back down we will have a push 0 label, transitioning back to Q1. So I'm going to write this kind of complicated pushdown automata, and then we will kind of go through it and see what it's doing and what all this notation means. Okay, so so similarly, we're gonna have another state here, Q4. Okay, and here we're going to pop the 1. Okay, and then finally we will pop diamond. Okay, and then we will get to Q5, and Q5 will be an accept state. Okay, so this is going to be a pushdown automaton. Okay, and this pushdown automaton, you can see that its arcs are sometimes labeled just by, so sometimes you have an arrow with just a label like 0 or an arrow with label like 1, and you know what that means. This is the same as what it means in an NFA. You have to read a 0 or read a 1 from the input in order to take this arc and go somewhere. Okay, but also sometimes we have an arc that's labeled by pushing something, some symbol, pushing a symbol 0 or a symbol diamond, or an arrow that popping. So the arrow is labeled by a down arrow symbol or by an up arrow symbol. Okay, and oops, this is going to be, sorry, I mean for this up arrow to pop a 0 here. Okay, so so we have these arrows that are kind of labeled by other arrows. Okay, and what is going on here is that this machine, its behavior at each point in time is not only going to be determined by which state it's in, and also by the input it's reading, but also in addition to that, it's going to have like a stack. So let me write this here. It's going to have a stack on the side, kind of, and the stack starts out empty, but it can place and remove, delete things from the stack, from the top of the stack each time. So let's just run this machine on the input 0011 for a second to see what happens. So this machine will start at Q0. Okay, so it will start over here. And then the first transition it has to take, there's no other options here. The first transition it has to take is this pushing down of this diamond symbol. And what that means is that we have to place diamond over there in the stack. So now we didn't read anything from the input yet, but now we are in state Q1 and our stack is different. Our stack changed. Our stack has a diamond. Now from Q1, we have two choices, right? We can either take this epsilon transition to Q3, okay? Or we can read a 0 from the input and go to Q2. Okay, now if we take this epsilon transition, then our only other options will be either to pop the diamond from the stack or to read a 1. Now we can't read a 1 from the input because we didn't read this 0 from the input yet. Okay, so suppose we take this epsilon path from Q1. Suppose we take this epsilon path. We will not be able to take this 1 path because we can't read a 1 from the input. So we have to pop the diamond. And when we pop the diamond, we delete it from the stack. Then we will be over here in Q5 and our stack will be empty. Now from here, there's no more transitions, so we can't go anywhere. And it's an accept state, so that looks good. It looks like we're going to accept. Except we didn't read our input yet. And in order to accept for an NFA or a pushdown automaton, in order to accept in either one of these machine models, you have to read the whole input. It's not okay to just reach an accept state. You have to reach an accept state after you've done reading the whole input. So we're sort of forced to move forward and read a 0, but there's nowhere to go from here. So we cannot read a 0. So this path rejects. So let's backtrack a little bit. Let's backtrack and we'll put the diamond back in the stack and we'll return to Q1. And instead of taking this epsilon transition, we will take this transition labeled 0. Okay, what that does is we're going to read this 0 from the input. I'll underline it to mark that we read it. And then we will be over here in Q2. Okay, and from Q2, we have to take this path down and push 0. The down arrow means push, and we're pushing 0, which means we have to put a 0 here on the stack. Okay, hopefully my 0 doesn't look too close to a diamond, but we pushed a 0 to the stack, and now we're back in Q1. Okay, now again, we can take an epsilon transition, okay, but let's try it. Suppose we take an epsilon transition, then we can either read a 1 from the input, but there is no 1 in the input, the next symbol is 0, or we can pop a diamond from the top of the stack, but the top of the stack has a 0, so we actually cannot take this transition. It's not possible to pop a diamond from the top of the stack if the top of the stack has a 0. So we can only ever affect the top of the stack. We can only affect the topmost symbol. We cannot reach this diamond underneath. We cannot see it. So when we're at Q3, there's nowhere to go right now. We cannot pop the diamond from the stack because the top of the stack is 0. So we cannot take this arc. We can also not take this arc that reads a 1 because the next symbol of the input is a 0. So if we take epsilon transition, then we will be stuck. So we cannot take this epsilon transition and we have to follow this 0 path again. We read another 0, we end up in Q2, and then we push another 0 onto the stack, and then we end up again in Q1. Then we will take finally this epsilon transition because we cannot read a 1 starting from Q1. So we'll take this epsilon transition, arrive at Q3. Then we will read a 1, arrive at Q4, okay? Pop a 0, deleting it from the stack. Okay, and then again, we will read another 1, okay, and pop another 0. And finally, we end up here at Q3, and then we take the last arc to Q5, popping the diamond, okay, and we end up with an empty stack, and we read the whole input, and we're in accept state, and then we accept. Okay, so this is a pushdown automaton. A pushdown automaton accepts a string if there is basically such a path that reads the whole input and reaches an accept state. Pushdown automata are always non-deterministic. We will not deal with the deterministic pushdown automata in this class. And this particular pushdown automaton accepts the language 0 to the n, 1 to the n. It recognizes this language. Okay, it's exactly the language of this pushdown automaton. So the pushdown automaton are equivalent to context-free grammars. This is shown in the notes. I won't prove it in this video. The proof is a little tricky. And yeah, these are the main thing I wanted to show is kind of give an example of it to get a feel for how it works. All right.